And this has to do with constructing algebraic expressions. If there's one thing that's hard for many people is to do the so-called word problem, the story problem, or you know, the fact of the matter is that's the way problems present themselves in real life. So we're going to talk about this in segments. So I'm going to talk a little bit about setting it up right now. And you're going to have a few exercises on translating these algebraic expressions from plain English to algebraic symbols. But then a week from Monday, we're going to talk about word problems in general, a good strategy for going through word problems, and it'll be based on this. So the goal is to translate language into symbols, mathematical expressions, equations, and also making models too. And so really the key to doing this is is understanding the structure of language, where we're using several keywords for the operations. And I'll tell you what the keywords are, what I mean by keywords. We want to use variables and numbers to represent quantities. And this may seem like it's a trivial thing to say, but variables that you define should always be a quantity. It shouldn't just simply be a name. And then you look at the verbs, and many times it's the passive verb is. Sometimes it's is greater than or is less than, things like that. But you use your verbs to establish the relationships. So here's a simple one. Okay, the pencil is 20 cents more than the pen. All right, so we look at the pencil and say C is the pencil cost. Is means equal. 20 cents is just 20 cents. More than. Now that's what I mean by keywords, is more than is what you use for your operations, and then the pen. P is the cost of pen. And so if I make one point here, it's define your variables. So many times it's easy or it's tempting just to want to slip into an equation. But here I have an equation that has, an equation that has two variables. So I could have called P the cost of the pencil, but then I would have to name P the pen, the cost of the pen, something different. And so it's your choice what to determine or what to name your variables, but do it explicitly, write it out. And so when I condense all this, I get C equals 0.2 plus P. All right? So these keywords, with addition you might see with a sum of, or you might see plus, or you might see greater than. Subtraction, you see minus, less than, difference. In section 1.5 in your book, they have a list of maybe a half a dozen of these including a few more. And so one of the homework assignments that I want is that you look at section 1.5 in the book and read those, and see if you can construct 3 more in each category. So 3 that involve addition, 3 that involve subtraction, 3 that involve multiplication, and 3 that involve division, and give me an example of it. Okay, so if I say an example using the word sum, that an example would be the sum of your ages is 25, or the sum of Bill and John's age is 42, or something of that sort. So you'll see this on Moodle as part of the assignment, but just to give you a heads up, I'm not going to go over each and every individual one. I scanned through a couple algebra books a couple months ago, and each of them had a different list. There's no set defined list. It's just you have to think in terms of what are these keywords, what are the things that you're looking for, and they're oftentimes the first thing that you use to unpack a sentence. My purpose in having you give an example is that how you use these things. When you say Bill's age is 5 years more than Sue's age, do we add or subtract 5 to Bill's age or Sue's age? You know, that kind of thing tends to be the hard part of establishing these relationships. So by constructing an example, you'll kind of get into the groove of where you place these words and what meaning does it really assign. Now, defining your variables, okay? You can use any letter you want. Use one that reminds you of the quantity, of its meaning. And what I mean by that is that x is always used as a variable, n is always used as a variable when it's usually an integer or a count or something like that. Use other letters, make it a little bit more vivid for yourself. Like if you're trying to find the length and width of a rectangle, L and W are logical there. If you're trying to figure out things like if it involves quantities of people, if it's, say, their ages or something like that, it's the first letter of the first initial of their name. Now you're going to have conflicts because we only have a small number of letters, and there's ways of dealing with getting more variables. But for now, with the kinds of problems that we're going to do, just make sure you define your variables. And make sure that it's the quantities, okay? B is not Bill. B has to be something about Bill. Bill's height, Bill's weight, Bill's age, whatever. And then also include the units. You guys know about the Hubble Space Telescope. It's at the end of its life. It's one of the most fantastic telescopes of all time. When it was launched, they were really bragging about how fine of an instrument this was going to be, that they said that if you made the mirror as large as the Gulf of Mexico, that the curve of this mirror would only deviate by 1/8 of an inch. It was so accurately done, and it was accurately done. The problem is it was done wrong. And so when they put it up there, the guy who started it up couldn't get Hubble to focus properly. It had something called spherical aberration, which means that the outer part of the mirror focused at a different part than the inner part. And so they were really disappointed. So it cost, I don't know how much it cost to run a shuttle mission up there, certainly in the hundreds of millions of dollars. And they put in some lenses to adjust that. But it took them a while to figure out why they made this mistake. And it turned out that it was one lonely engineer who didn't do a very good job of saving his calculations, but he used a formula that was in centimeters, and he used a measure that was in inches. And so it was either that or the other way around. He used centimeters when he should have used inches, or he used inches when he should have used centimeters. But it was a $100 million mistake. Nobody found it. In fact, it took him a couple weeks to figure out why he made that mistake or what the mistake was. So my point of the story is twofold. Number one is make sure you write everything down, including the units of your variables, because that will help you ultimately. Minutes are different than hours, and if you do a calculation in minutes, you're going to get a number that's 60 times the size than if you did it in the hours, even though its meaning may be the same. Number two is, not just for this class and being able to check your work and check your exams before you turn them in, ultimately when you get out into the real world where you're managing your own budget, or where you're working on behalf of some employer, or maybe you have your own business and you're doing your business plan or whatever, the more you write down, the more you see what you've done. And so chances are you never do a problem just once, you do it several times. Have enough notes where you can see what you did. And so, keep a record of what you do. And so I want to get you into the habit of making great variables. A meaningful letter, something that actually represents a quantity, and something that has some units. Okay, so here's some examples. Like B would be Bill's age in years, or N is the number of dimes. Now, the number of dimes doesn't have units, right? That's a count. So when I say number of dimes, you should recognize that that's a count. The value of dimes is different, so I'm putting that in dollars. Now, the value of a dime could either be 0.1 or 10. I'm saying it's in dollars, so the value of a dime is 0.1. The length of a box in inches, the area of a square. You can use capital letters. Traditionally, when you're using things like area and volume, you use a capital letter. For linear dimensions, you use a smaller lowercase. Doesn't matter. If you're really fancy, you can even use Greek letters if you want. Poor examples is just B equals Bill, or D equals dimes, or X without any definition. Now, oftentimes we're just doing examples of just simplify this, where X really doesn't have any units to it. And that's okay. You know, those are just, you know, very focused kind of exercises. But in general, when you're problem solving, you almost always have units, so be sure you include them. Okay, so we have this idea of constructing a model too. And what a model is where you translate what you have in terms of an understanding of the world or an identification of a problem, or somebody gives you a problem that's written or something like that. And what you do is you kind of make this pseudo equation. You want to write what you know and how you're going to calculate it, not really too concerned about your symbols, things like that. Like, let's say I have some change in my pocket, and I know they're quarters and dimes, and I want to know how much money do I have. Well, my model for that is I take the number of dimes, multiply it by the value of the dimes, the number of quarters, and multiply it by the value of those, and add those two together. So this is the model. Now, I haven't defined much other than just said in words what the way of calculating this is. So I'm going to go through and I define my variables and I apply my quantities. So I'll say D is the number of dimes, 0.1 is the value of dimes in dollars, N is the number of nickels. Did I say quarters up top? Look at that. I'm mixing dimes and nickels here. That model should have been nickels, or the variable should have been quarters, but I think you get my point here. And so then you rewrite using the definitions, or you rewrite your model using the definitions you've just made. And so the amount of money you have between nickels and dimes is literally from the model is D times 0.1 plus N times 0.05. You can rearrange that to make that a little bit more conventional, and so you say 0.1 D plus 0.05 N. Okay, now this is 3 steps that we're going to use in terms of making word problems. There's going to be a total of 5 steps that we're going to use. And whenever we have word problems, I'm going to expect not necessarily that you identify each step, but that you do each step. That you make a model, that you make your definitions, that you write your relationships based on your model. Now steps 4 and 5, which we'll get to, 4 is what you normally think of as the problem, is you're going to do the algebra to figure out what your variables are. And then 5 is going to be answer the question. And I'll talk about why that's separate from calculating the values of your variables at some later time. Okay,